So a few words about me. I work for RCE Group, as you can see from the slides. I'm a managing security consultant and office research lead in the letterhead office of RCE. I have more than 10 years of experience in offensive security. You can find me on Twitter under X or EIP, and of course on LinkedIn as well. I have a few strictly technical certificates. I like to do research and other stuff. These are listed on the slide. And I'm a frequent speaker on other conferences as well. I was fortunate to go around the world in the last few years and then give presentations about different topics all around the globe. Today I'm going to talk about this device, which might be familiar to you. This is from Virgin Media. This is the Hub3 or Superhub 3. This is the latest, the last version of these devices as far as I know. If you have a subscription with them for broadband, most probably you will get or you already got this device. Hands up, please. Who has this device? Yeah, many of you. That is great. No, it's not that bad actually now. So I moved to the UK 3 years ago in 2016. We moved into a flat and we decided to get Virgin Media. And actually we are pretty, their service is really good. So we had no issues, but because it was a new country for me, I didn't know anybody. I was home most of the time after work and the weekend, so I had to do something. So what did I do? I started to play around this modem, and after one day, I found one remote command execution bug. So this is how this journey started. In January 2017, I asked for some research time from NCC. It was granted by Matt Lewis, the research director. I got 2 weeks, and on the first week, I managed to discover more than, 5 issues, and then I bricked the device. So I had to stop it, and we had to buy some new devices from eBay. So it's really strange, at least it was really strange for me. Basically, if you go on eBay, you can buy the same exact device in bulks sometimes. So we bought like 6 of them, and I continued my research. This is a very well-known device. Many people are using it. If you go on Wikipedia and read about Virgin Media, you will find that as of end of December 2012, they had almost 5 million cable customers, and 4.2 million customers had broadband internet access. And at that time, those customers didn't have this device. But since then, because it's 2019, as you know, many of the customers were upgraded, let's say, or new customers already, they were given this device. So, give or take, I think there were millions of customers in danger when I discovered this issue, and it was a long journey. You will see why. So how did I do the penetration testing of the device? I started with discovery. So I scanned the device externally, and it came back with nothing. So everything is filtered. Nothing is exposed to the internet, which is a good thing. You can expose the web UI, the administration interface, which you shouldn't do ever, and please don't do it. That's not a good idea. But internally, you will find 3 different ports, port 80 and 443 for the web UI again, over HTTP and HTTPS, and port 5000, which is mini UPnPD. I tried to break the mini UPnPD, but I didn't succeed, so that looked fine. So I started to play around the port 80 and 443, which is basically the same. So my goal was to basically take over the device, execute any kind of commands and codes on it, totally own it. which I later did. But when I set the goal, I had to figure out how to do this. The best way to start, if you want to do the same on different devices, or maybe the same device, if you want to do this, you should find those functionalities on the web UI on the device, which are really close to the OS level. For example, if you configure the wireless, then you can set the ESSID, the passphrase, and so on. If you do MAC filtering, then you can set different MACs. Or do port forwarding, you can set different IPs and ports, and so on and so on. Those are usually executing different OS level commands in the background. Ping and traceroute, those are the perfect example. Most of these devices are owned through these functionalities. That's how I did it as well. Basically, when you use the ping and traceroute, they didn't implement their own ping and traceroute in the binaries. They just use the external ping and traceroute binaries on the operating system. So I started to play around with those. I set up a burp, proxied everything through, and what I saw were these requests. And as you can see, it says all of them are GET requests. And SNMP gets, SNMP sets, that's the name of the endpoint or the function, which is really strange. Because if you know SNMP, that's a totally different protocol than HTTP, and one has nothing to do with the other. So I was really surprised. And the web UI the browser is sending so many of these requests that the burp couldn't handle it properly after a while. So it was really strange. So I started to look into this, what's this? And it turns out that the device, the web server using SNMP, let's say, to set the configuration, to get the configuration and display in the browser, and to execute different commands as well, different functions actually. So as you can see here, in the GET requests, in this example, there is SNMP set, there is an OID or a MIB, which we know from SNMP, and there is an equal sign, a value, which is 1, semicolon 66, which turns out that's the type of the value, which I don't know in this case, what's that? But anyways, after that, there is the underscore N underscore, which is the anti-CSRF token, which is kind of dodgy, but it kind of worked as well, so that's kind of fine. And one more thing that you need to see is the credential cookie, which is a base64 encoded string. That's a JSON string. It stored some kind of session identifier, like a session ID, and a few other things as well. So it's really strange because SNMP is a different concept. They mixed it up for some reason. I never seen anything like this. I don't know why they did it, but that was a choice that they made. And with this, through HTTP, the device was able to set different values, get different values, and most importantly, execute functionalities from the web server's binary. For example, when you use Traceroute, these are the different SNMP MIDs or OIDs that had to be set. The first one, the 0 one, was set to 16, and the type was 2. The type 2 is integer, that's what it means. I guess that was the maximum TTL for the command. The second OID which was set, that was the host name. The type is 4, which means string in this case. Then the third one was set to 1, whatever, and the fourth one was set to 16, not 16, to another number. These are integers, and the end, the 7.0, that was basically the execution of the command. If you set that value, if you set that MIB to a value, then it will execute a function in the binary or in a library. So I managed to do the remote command execution. I got the binaries, I got the libraries, I started to reverse engineer them. I used IDA, and as you can see, this is using ARM. So when you do these kind of remote command execution bugs, you should look for string injection points first, because if you try to play with integers, there is a higher chance to fail, because integers are really easy to validate, really easy to sanitize, because those are just numbers. It's not the same for strings, because in some cases you need special characters. It's harder to implement whether it's harder to check whether the string is valid in that scenario or invalid. Sometimes you do whitelisting, sometimes you do blacklisting. It depends on the use case, but it's harder to do in general than in integers. So as you can see, this assembly snippet basically executes the traceroute command first. It's using smprintf that assembles the string. There is two s placeholders in the string, which are the strings that will be put in there, and the return value of the smprintf will be executed with the system call with the system function. So based on this, if you can control one of the s placeholders, the percentage s placeholders in the string, then you can do command execution. This is Hextrace from IDAPRO. I not only disassembled but kind of decompiled the code as well. As you can see, there are three different ways to execute Traceroute, whether it's IPv4, IPv6, or DNS, which means in this case, if it was a host name, if it wasn't an IP, then it goes into the third branch. And you just using smprintf again, there are a few placeholders, actually 4 placeholders at almost the last line, and then it's using system on the string. So if you can inject any of those placeholders, and if you see the command, the first argument after the string is a string again, which is hard coded, so you can't really do anything with that. The second one is the destination. Maybe you are able to control that. v28, that's again a variable, so you might be able to do something with that. But the fourth one, the last one, the var temp, whatever, that's hard coded, so you can't really do anything with that. The question is, can you do anything with the dest and v28? And in this case, you can, because that one of that is basically the host name that you can't control. So, this was a working remote command execution vulnerability. It is quite easy to figure out how to exploit this if you have the source code, or if you have the binaries and you can reverse engineer it. I didn't have either of those, so I had to do it blindly. When you do it blindly, there are lots of different ways where you can fail, because you have no idea how it works. So you need to do everything step by step, baby steps. And if you are lucky, you have feedback from the device. If you are not lucky, and I wasn't, you don't have any feedback. So you need to find something out. So even if you inject a valid command, you can't see the output. You have no idea whether it run or not. There are different ways to execute code in commands in this scenario. In this case, you can use backticks, pipes, semicolons, or inline execution, as is listed on the slide. But you cannot be sure which is going to be working. For example, the semicolon didn't work because that was a restricted character for some reason. Because there was no feedback at all, I had to figure out a different way to do this. So first I used reboot. And the first time I managed to reboot the device, I was really happy, because I knew something is going on, right? So I had to wait a few minutes because it's booting really slowly. I had to reproduce everything with a different command. Then I used ping. I pinged my Kali host where I had a Wireshark running, and I was looking for ICMP pockets. And when I got a first bunch, I was really happy about that. The other thing that you need to look out for, sometimes the path is not set properly. So you need to go with full path, with absolute path to the binaries. It can, for example, if we are using ping, it can be under bin, user bin, or sbin, whatever. It depends on the operating system and how they set it up. In my case, I couldn't use space, single quote, semicolon, or backslash either. So I had to figure out a payload which was working properly with these restrictions. First of all, you don't really need backslash. Backslash is for escaping, but you can bypass that by using different kind of ways. Single quotes, if you use encodings, you don't really need single quotes, so that's fine. Semicolon, I don't know if you remember, but when you send the OID to the value, at the end there was the type of the value, like 2 for integers, 4 for strings. And there was a separator when you set the value, that was a semicolon. So I couldn't use semicolon in this case because that was a separator in the web server. So I had to figure out something else. But instead of semicolon, you can use just double end signs or pipes, double pipes, real line execution, maybe backticks. There are different ways. And if you don't have space, you either use different white space characters, but the best way is to use the environment variable IFS, which is basically a set of white space characters, space, tabulator, new line, carriage back, and these kind of things. And if you use that, it will understand the command without space. That was one of my payloads that I sent. In this case, I used a valid hostname for no reason. That's just to prove you how it works. And then I used inline execution, where I connected back to my IP, which was my Kali VM. I set up a listener on that host, and when the telnet was run on the device, it connected back to me, redirected everything, which was the content of the shadow file. So the content of the shadow file was redirected into that socket. So I got the content of the shadow file, and everything else went to dev norm. After the remote command execution was exploited, like I mentioned, I got all the binaries and libraries. I started to reverse engineer everything that seemed to be interesting, and I found this little snippet which wasn't working in this firmware, and I don't think it works now. But it was really interesting to see this. So basically, this is a backdoor user. If you use an unme user, the password is either a blank string or suddenlink. And as far as I know, Suddenlink is a different vendor, like a different ISP. So maybe with that ISP, there is a backdoor user which you can use on the web UI with the password of Suddenlink. I found that really interesting. Yeah, about this device, it is branded as Virgin Media, but really the device is not Virgin Media. This is a different vendor, which I can't mention it for stupid reasons. And basically they sell this as a white label device for different ISPs, and Virgin Media belongs to a different group, which is Liberty Global, I believe, and Liberty Global has many different ISPs all around Europe, and I believe in the US as well. So they use the same device for different ISPs. The box is different, the logo on them, the brand, the configuration is different, but the operating system and the binaries and the firmware is kind of the same. This is basically, they don't want to develop the same things for different ISPs. Okay, so looking through the web UI, you don't need the firmware for this. I was looking through the JavaScript files. I found a DOM based XSS. Authenticated DOM based XSS. So if you log into the device and then you click on a link, a crafted link, which can come from an email, a phishing email, or somebody else can send it to you somehow else. If you click on this, for example, which is on the slide, then it will load up the nccgroup.trust/test.js, and it will execute the JavaScript from that file. So if you're logged in, you click on this, I can execute any kind of JavaScript in your browser. I can see your cookies, which are used for authentication, as you remember from the first HTTP request that I showed you. And maybe I can log in or I can do stuff with your browser. My goal was to do unauthenticated remote command execution. I had the authenticated remote command execution part, but I had to make it somehow to be unauthenticated. So I had this DOM based XSS basically, but that needed authentication. The UI wasn't exposed to the internet, so even if I have the credentials, I can't log in because I don't know the credentials, and it's not exposed to the internet. And maybe you remember I mentioned the anti-CSRF tokens. So those were protecting against malicious web requests that are coming from a different website. Then I looked through the binaries again. I was looking for the authentication part, authorization part, and I saw this snippet of code where you can see if the credential content, which is basically the cookie, the credential cookie, if the content of that equals XML configure, HNAP configure, or TACOX configure, there you are logged in, right? Otherwise, it says status denied and you are a loser. So that was really good stuff because it wasn't just an authentication or authorization bypass in this case, but it bypassed the anti-CSRF tokens as well. So I didn't have to worry about that. So it was really cool because if I set these cookies, I use maybe the DOM based XSS and then the remote command execution, then I might be able to do some unauthenticated remote command execution, right? The only thing is CORS. I don't know if you know CORS. Cross origin resource sharing. Hands up if you do. Yeah, half of you. That's fine. So basically, long story short, what CORS does, if you have two different web pages open in your browser, one web page cannot access the other's data, right? So I cannot, if you have BBC open and my malicious website that I control, I cannot set cookies for BBC. I cannot get the cookies from the BBC site. I cannot load or get any content from the other tab from the other browser, right? So that's basically the cross-origin resource sharing in the shorter version. Of course, it's bigger than that. So I was thinking about this. Maybe I can use the DOM based XSS with the cookies, the bypass cookies, and execute these SNMP sets requests remotely, or somehow I can do this. But there was the CORS, of course, which was blocking me, so I couldn't do this from the browser. And even if there was a valid session because somebody just configured the router and clicked on the website in the next 10 minutes or the next 20 minutes, I couldn't do this because the session timeout was quite low. It was like 5 or 10 minutes. So the auth window is very narrow. So I had to stop working on this. I couldn't do unauthenticated remote command execution on that time. I wanted to weaponize this as an exploit, but I couldn't, at least not in a way that I wanted. So I did some other research on the device. I started to look in the architecture. You would think this is a really basic device, nothing special. It's running Linux and that's it, but that's not true. So this is basically a Wi-Fi router on 2.4 and 5G. This is a router and a DOCSIS modem. So it's more than you would think. I started to look into the file system, and it turns out there are 14 different partitions on the flash. And 4 of those partitions had 2 different Linuxes, one for ARM, and the other one was for Intel 886, which was really strange because I already owned the ARM part. So why would you have Intel 86, x86 binaries and an operating system on the flash? That was really strange for me. Then I checked the ARP cache, and there was this IP 192.168.254.254 on that interface, which is in red, which is a different VLAN. So it was quite strange. So I decided that I am going to ping it. And as you can see, there is no latency. So it might be a kernel hack for some reason, which is really strange, or there is basically no wire between the two operating systems, or a really short wire. And it turns out this CPU that the device is using is an Intel Puma 6, and in 2016, early 2017, if you Google this chip, you didn't find much about it. I don't know why. Probably it wasn't well spread that time. But anyways, it turns out it has 3 different cores on the chip. One is ARM v6, as we know. I already own that architecture. And there is 2 other cores which are Intel x86, right? So 3 different cores, 2 different operating systems running on the 2 different kind of architecture, which was really strange because we are talking about one CPU. ARM and Intel is integrated in the same CPU. I never seen anything like this before. Then I started to think about maybe I should own the other parts, other half of the device as well. How can I do that? There are 2 ways that I came up with. The lazy way is basically modifying the FS, the file system, rewriting it or changing some stuff on it. Or the other one is service exploitation. So I went with the lazy way. There are a few partitions that are used with by the secondary architecture. One of them are squashfs, which is read-only. So you need to get the file system. You need to dump it. If you want to change it, you need to rebundle it. You need to recreate the whole file system because it's read-only. And you need to reflash the flash. That's not hard to do, but it's kind of risky because if they have some kind of signature checking or any kind of other stuff, it might break the device. So what I did, I mounted the X3 partition just to see what it does. I wrote on it, I rebooted the device and I bricked it. So after 1 week, actually after like 4 days, I bricked the device because I wrote onto the X3 partition, unmounted it, but I forgot about the secondary architecture that was already mounted. So when I rebooted the device, it marked the partition as corrupt, or it needs to be FSCK'd. But when you reboot your computer and it needs to be FSCK'd, it is asking a question from you, and you need to write yes or no during the boot, but basically you can't really connect a keyboard or anything to this. So that's how I bricked the device. Every time when I rebooted, it didn't boot because it was waiting for my yes answer. So it was quite unpleasant. I had to go get a new device. So that's when we ordered lots of these devices. Regarding squashfs, if you decide to recreate it, then you need to make sure that you use these same compression algorithms. You check all the files and everything just to make sure that it is going to work. Because if you reflash it wrongly, then it's not going to work ever again. Or, of course, you can get the flash, you can connect to the flash, but you need to get out of the case, and that's not something that I can do. The other way, after I broke the device, I had to do the other way, which was basically the service exploitation. I scanned the secondary architecture on that IP that I showed you. I found one really old Samba, which was 3.x, with no shares. There was a public exploit in Metasploit which was working against it, but should have been working against it, but it didn't, so I couldn't do anything with it. There was an RPC client bound to the 10.23 TCP port and some unknown services. Then I dig deeper and I found this port, which is 5150, I believe. Yeah, I hope you can see it. And if you read in the middle, there is this command system. So basically with the system command, you can execute any kind of operating system level command. So I decided to execute a drop bear SSHD on port 22, and I was in. It was quite trivial because the password for the root user was the same as on the other architecture, and by the way, I had access to the file system, so it was quite easy to log in. As you can see, this secondary architecture was running and still running on Intel x86, and the other part, which is doing the logic, is ARM v6. Then a few months later, I came across this thing, which I completely ignored so far. And I was thinking maybe I can do unauthenticated remote command execution finally. So as you remember, the only bit which was missing here is bypassing cores. So I quickly booted up the device when I realized maybe I missed something, and I sent a request. This was the response for it. The host header was set to the IP. Then I changed the host header from the IP to whatever, doesn't matter what you change to, and I got the same response. Can you tell me what kind of vulnerability is this? Yeah, that's right, DNS rebinding. I think there's a reason why you know this. Yeah, so DNS rebinding. And basically this is the San Grail to get the unauthenticated remote command execution working, because with this you can talk to the device remotely, even if it's on the Ethernet network. So if you don't know DNS rebinding, it's really easy to understand. If you have a hostname that you control, then when you resolve that hostname, it will give you an IP. And if you resolve that hostname for the second time, it might give you a different IP. And the browser will think that it is talking to the same web page, but the IP changed in the meantime in the background. So in this case, I created a demo, which I'm going to show you. I really hope it is going to work. If not, I have a video of it, so you can see it like that. So basically, I have a domain which is pointing to a website which is externally available. You can open it in your browser, and after a few seconds, or in this case because I was lazy and cheap, after 20 to 120 seconds, it is going to change the IP behind that hostname, and the browser will talk to the device, to the router. This router has by default the same IP all the time, which is 192.168.0.1. That's basically the default. You can change it, of course, but nobody changes it. So my exploit is going to change the external IP to this internal IP, and the browser will think that it is sending the request to the same device, to the same server, but it doesn't. So what my exploit does, when you open this website, because I send you a link, or it is embedded into a website that you visit frequently, and it is going to work in the background. So when you open this website, it will set the cookie to that bypass cookie that I showed you. I can do that because I execute my code in my own web browser, right? In my own domain. Then it is going to wait, and in the background I do some magic to do DNS rebinding. So I have my DNS server which tells for the first time this is the external IP, this is the website. Then if you ask it again, it will give you the internal IP of the device. So after a few seconds, or more than a few seconds, the browser will change the cache the IP will point to this device, and I'm going to start that time. I'm going to execute the auth against the device that time. I will send a lots of SNMP set requests to set the traceroute things that I showed you in the beginning, and basically it will execute the drop bear SSHD on the main architecture, on the ARM part, expose that port on 22, then it will exploit the secondary device, the secondary architecture through that service that I showed you. It will execute a drop bear on the secondary device, and with some IP tables magic, I will expose that port, the secondary SSHD port on port 23. So demo time, fingers crossed. So I have my DNS server running on my server. This is not that important, I just wanted to show you. And here I'm going to scan this device. As you can see it, right? You can read it. Port 23 closed, port 22 closed, so everything is closed. I have internet access on this Kali VM. Google loads properly, it's fine. And I'm going to open this crafted website, which is the Virgin Media Hub exploit that I wrote. It started the attack, I set the cookie, and as you can see here in the bottom, it is going to send like in every 20-ish seconds a request to the device. It's a 404. It is looking for a PNG, and if it's 404, that's why, because we don't have that PNG on the server that I serve, right, on the web page that I serve. But when the IP changes after a while, hopefully it's around 60 seconds and not more, then it will look for that picture on this device. That's how I know the DNS3 binding works. And when that happens, we know from the JavaScript that we are talking to the device instead of the web page that we serve, and we are going to do the exploitation. Okay? So it wasn't 404, it was a 200, so we found the picture, and now we are sending a lots of SNMP stuff. Like I told you, I was cheap, and I was lazy, so that's why I'm using this DNS3 binding technique. There are different techniques. There are more reliable, but more expensive techniques in terms of effort and resources. So basically, you can use those, and you can do DNS binding in a few seconds. So when you open a malicious web page with this setup, maybe you can be exploited in 3 seconds instead of 65, 7, right? So if we go back and scan it again, you can see now port 23, 22, and 23 is open. So I can log in port 22. You don't really get a shell, like you can't see it. As you can see, I'm root, UID is 0. This is the ARM architecture. One core, RV6, Puma 6, yeah. And I log out, don't need this shell anymore. And I log in on port 23 with the same password, and I do the same stuff. Two different cores, but both of them are Atom, which is Intel x86. Basically, that was the demo. And few seconds. The question is here that if you get hacked this way, and you won't be hacked this way because all these issues are fixed except one, which is DNS rebinding, or maybe that's fixed as well. I haven't checked for a while. So basically the question is, if you get hacked and somebody implants something in the secondary architecture on the atom part, would you ever notice it? Do you think that the forensics that you do against your device or somebody else does it? Will they pick this up? So I think it's quite frightening because you don't know anything about these devices. It can have lots of different issues, and even if those issues are exploitable, they can hide their stuff in the secondary architecture, and you can't really do anything against it. And from that architecture, you have full access to the interfaces. You can change the data, you can spoof it, you can sniff it, you can do whatever you like. In NCC, we do responsible disclosure, which is great, but in the same time, it's kind of annoying. So I reported the issues in March 12, 2017, 2 years ago, more than 2 years ago, and it took around 1.5 years to fix all the issues. I mean, I understand the process. I think I understand the process. It's really slow. They need to test the firmware. They need to make sure that everything is fixed. And they really need to make sure that everything is working properly, because if they roll out a firmware which is faulty, then they will break hundreds or millions of devices. Millions of devices, and that's financially not a good idea. So probably that's why they took it really slow. But 1.5 years, and I couldn't publish this talk, couldn't publish anything about this because we were waiting on the vendor. Thank you so much. If you have any questions, then maybe you can do it now. I believe we have 5 minutes. We have 5 minutes, but otherwise, if you don't want to have questions here, you can find me later on the hallway or in the evening having beers. So thank you.